Okay, so let's do with the hybridization now. What is hybridization? Hybridization is nothing but, it's the literal meaning of hybridization is nothing but mixing. Whatever you mix, that doesn't matter. Okay, it is mixing. Literally, I'm asking literal meaning. I'm not going any science, any chemistry, nothing. I'm just asking the literal meaning of hybridization. Okay, hybridization, mixing. Okay, simple mixing. Okay, so now we are going to use it as the hybridization for the explanation of the structure of the molecule. Okay, chemical bonding and all these things we are going to start. Okay, so first one I'm going to take the example of BeCl2, which you wrote BeCl2. Clear? BeCl2. I think you know what is the hybridization because you had wrote a column, right? But I didn't explain the column. There we wrote it as SP, right? We wrote it as SP. The hybridization we wrote it as SP.
Yes.
But why it is SP? What is SP? We don't know. Let us just find it out. That what is SP? Okay. Try to understand. It's again basis is completely based on the valence bond theory, VVT. Okay. What is the central atom over here? B. B is the central atom, and we know B is forming two bonds with two chlorines. B is forming two bonds with two chlorines. Yes. So Be needs two orbitals with unpaired electron according to VVT. Be needs two orbitals with unpaired electron because it will form two bonds for overlapping, and Cl, each Cl needs one orbital with unpaired electron. Each Cl needs one orbital with unpaired electron because it has to form a bond with Be by overlapping. That is VVT says. So let us see what is the condition. B. I'm going to write down the electronic configuration of B. You are going to do it with me also simultaneously. B in its ground state. Please do it with me. Ground state. Ground state means in normal condition. In normal condition. In normal condition, B has got electronic configuration as what? Electronic configuration as 1s2. B has got how many electrons? 4 electrons, right? So 1s2, 2s2. 1s2, 2s2. Okay? So let us write it in the box form. Let us write it in the box form. 1s2, 2s2. Yes? Fine. Now tell me, is it ready to form any bond? Is it ready? Be is ready to form any bond with this electronic configuration? The answer is no. Why no? Because there is no orbital with unpaired electron. No orbital with unpaired electron. We need how many unpaired electron? 2 unpaired electron because B is forming 2 bonds. Okay. So it has to go to, this is again I am saying, this is just a theory we are saying. Okay. We are trying to explain the structure of BeCl2. Just trying to explain the structure of BeCl2. Okay. It goes to the excited state. It goes to the excited state. Now here this is 1s, this is 2s, but there is another orbital next to it is 2p which is vacant, where there is no electron. Now in its excited state, I will write it over here. We write it like this, Be star, that is excited state. One of the electron from the valence shell, and you know the valence shell electrons are responsible for the bond formation mainly the valence shell electrons are responsible for the bond formation. So one of the electron from 2s will jump over here and will get ready, B will get ready to form the bond. Fine. So you see, now what is the electronic configuration? 1s2. Now 2s there will be 1 electron, and 2p there will be 1 electron. 1 electron is jumped to 2p. Now Be has got 2 orbitals with unpaired electron and it is ready to form 2 bonds. I hope I could make the thing clear. That ground state has gone to, if ground state में अगर 2 अलग अलग इलेक्ट्रॉन होता था तो कोई प्रॉब्लम नहीं था. नहीं है तो हमको बनाना है. We need 2 unpaired electrons. So we made it 2 unpaired electrons by making it excited. Clear? So that 1 electron jumps to the next orbital and it is becoming now 2 unpaired electron. Fine. Okay. Now in this side I am drawing Cl. I am writing about Cl. Cl has got 17 electrons. which has got electronic configuration 1s2, 2s2, 2p6, 3s2, 3p5. Yes, that is the 17 electrons it has got. Let us draw it in the orbital formation. So 1s2, 2s2, 2p6, 2p. You know how to fill it up. You all know it. It's nothing new for you. 2p6, then 3s2, 3s2, and I'm writing 3p here because that is the important one in this particular case. 3p, how many are there? 5. 1, 2, 3, 4, 5. Is it ready to form one bond? Is chlorine ready to form one bond? Yes or no? Is chlorine ready to form one bond? It's ready, right? Because it has got one unpaired electron. So chlorine को हमको कुछ नहीं करना है. We don't have to do anything with the chlorine because it's already ready. Now please understand. Okay. Now if in this condition they form the bond, in this condition whatever is written, one bond will be formed between 2s. You see which orbital is this? 2s of beryllium with 3p of chlorine. One bond will be formed between these two by overlapping. Another bond will be formed between 2p. What is this? It is 2p, right? 2p of beryllium and 3p of the other chlorine. Two bonds at this condition, if the bonds are formed, the two bonds will be formed are different. One is between 2s and 3p and another is between 2p and 3p. So two different bonds will be formed between B and Cl. But the study suggested us, we know the structure already, so I will write down the structure. The study suggested that both the bonds, the bond between B and Cl of two bonds between B and Cl are exactly equivalent. There is no difference between the two bonds. But till now, whatever we had done according to VVT, till now we are in VVT. Okay? Till now, whatever we had done according to VVT, accordingly, these bonds are different. But our experiments confirmed that both the bonds between B and Cl are exactly same. They are exactly similar. Now, how can we explain this? Here comes the concept of hybridization. Try to understand. I am giving a very fake example, okay? But that will clear your concept. Suppose I have got two sides, two walls are there. Two walls of same size are there. Actually, if you come to my place, someday you will come and then you will see this room, this particular room. This is a study room actually. Study room means teaching room. So here, the walls are all white. As you can see behind me also the walls are white. Okay, the walls are all white. Suppose I want to color it. Okay, so I told someone of you that okay, get some color of your choice and you get it. So you thought that okay, sir's wall we will draw in two different colors. You got one red and suppose one yellow. One red and one yellow and you brought it. सर दिस साइड को रेड बना दो, इस साइड को येलो बना दो. अब जैसे आया, अब खरीद के लाया और वो वापस नहीं होगा. मैंने बोला नहीं, मेरे को एक ही कलर चाहिए, मेरे को दो कलर नहीं चाहिए, दोनों साइड में एक ही कलर चाहिए. हम लोगों के पास उपाय क्या है बताओ. एंड वन बॉटल और वन पैकेट नीड्स वन साइड टू बी कलर्ड. One packet needs one side to be colored, the other packet needs the other side to be colored completely. Okay, now tell me what is our way.
We have to mix the colors.
Very good. So if we mix the colors and then we paint it, then both sides will have the same color. We don't have any problem. So before coloring the walls, we are mixing it, right? Before coloring the wall, we are mixing it and then we are coloring it. Exactly the same. I hope I could make you understand. Before forming the bond with chlorine, बेरिलियम का जो दो इलेक्ट्रॉन्स है जो अलग अलग ऑर्बिटल्स में है, एक रेड है एक येलो है, एक रेड है एक येलो है, ये मिक्स हो जाएगा, ये मिक्स हो जाएगा। ओके, दे विल मिक्स एंड दे विल फॉर्म टू न्यू ऑर्बिटल्स, दे विल फॉर्म टू न्यू ऑर्बिटल्स। दो बटल कलर अगर आप मिलाएंगे तो दो बटल ही बनेगा। These two orbitals you are mixing and it is forming two new orbitals. Okay, जहां पे आपका एक एक इलेक्ट्रॉन्स है and these colors are same. These orbitals are having the same quality. Now this one of this is overlapping with the chlorine, one of this is overlapping with the other chlorine, and the bonds are exactly same. Now what is this hybridized orbitals known as? देख बेटा कुछ नहीं है, क्या क्या मिला है यहाँ पे, एक S मिला है, वन S मिला है, वन एक ठो वन मीन्स नॉट वन S, वन मतलब एक ठो S मिला है और एक ठो P मिला है, एक ठो S मिला है, एक ठो P मिला है, and hence the mixture is called SP. Hence the mixture is called SP. The hybridization is called SP. So you have the hybridized orbital SP, and it is overlapping with P, 3P. Now what is the nature of the overlapping? First one SP, B के साथ 3P, chlorine का. Yes. Second one also SP, B के साथ 3P, chlorine का. So दोनों orbital, दोनों bonding is exactly same. I hope I could make the concept of hybridization clear to you. Okay. So what is the concept of hybridization? Before forming the bond, to make them equivalent, we have to hybridize it, mix it, whichever we require. Okay, as we go you can see there are so many other complexities will come, that we will understand, but the concept is clear. Now just try to do it for BF3. Try to do it for BF3, the next one. Try to do it for BF3. Chalo, same way. I am not rubbing the board. Please try to do it for BF3. Same way. Same way. And tell me the hybridization of BF3. Without seeing the table. Don't see the table and tell. That is not my. You do it and then tell. B. Write down in the same way. Ground state. Whatever I wrote. Ground state. If required, excited state. The other atom. Okay. And then you write the hybridization. We write down the hybridization like this. So just give a second bracket over here. Then whatever number of orbitals are hybridized, you just make that many orbitals and put the electrons over here. That is hybridization, hybridized orbital, and give the name of this. Just the way I represented in the left hand side, exactly that. Only thing is over here that you have to write down the other atom's electronic configuration over here, whether it is ready to overlap or not. Generally in our syllabus it is ready. Okay, the second atom is ready. Yes. Yes, done. Now boron. Boron has got electronic configuration. Boron has got electronic. Also we are going to explain the structure of BF3. Right? Boron has electronic configuration 1s2, 2s2, 2p1. Draw the this thing. Okay, I'm not drawing 1s2. That's already there. Paired up. 1s2 and 2p1. Now this is the ground state. This is the ground state. Tell me how many orbitals are ready to form the bond. How many orbitals are ready to form the bond in the ground state? One. But how many bonds are there in BF3? Three are there. So you have to make 3 electrons ready, right? You have to make 3 electrons ready. Yes or not? So how to make 3 electrons ready? You have to go to the excited state. Yes? You have to go to the excited state where one of the electron from S will jump to P. So what will happen? S में एक इलेक्ट्रॉन रह गया, P में 2 इलेक्ट्रॉन आ गया. Yes or not? Now is it ready to form 3 bonds? Now is it ready to form 3 bonds? Is it ready to form 3 bonds now?
Yes.
Yes. But will the 3 bonds? Obviously, fluorine has got what? Fluorine has got 1s2, 2s2, and 2p5. 2p5, 1s2, 2s2 and 2p5, 1s2, 2s2 and 2p5. 2p5 means 1, 2, 3, 1, 2, 3, 4, 5. So is it ready to form the bond? That is fluorine, not chlorine, this is fluorine. Is it ready to form the bond? The fluorine is ready to form the bond. So don't have to do anything with the fluorine. We don't have to do anything with the fluorine. So that is ready to form the bond. But will the bond between fluorine and boron in this condition be same? No. So before the bond formation, what has to be done? They must undergo hybridization, right? So all three of them will undergo now three sides of walls. Three walls now we have to paint. Three colors are there. You understood that? So three are there. Now three new orbitals will be formed. Three new orbitals will be formed जहाँ पे एक एक इलेक्ट्रॉन रहेगा. Okay. And what is this hybridized orbital known as? You tell me. It is S. एक ठो S है. कितना P है? दो ठो P है ना? दो ठो P है. So you can say it as what? sp2. Okay. एक ठो S और दो ठो P. That is why sp2. So now I hope that you understood the concept of hybridization. Okay. And you can do for the remaining molecules.